take like this and all. So this is a fixed here. Let initial mass be m naught of the truck. Let's take this one here. Already we have discussed problem. Just some conservation of momentum is what I'm going to bring. No, so this is the same. That particular upper, or it's called as a chute. So that position of that will not change. Now where the truck will be. So the truck, let it be somewhere in this position. Try to see this now. So this will have some velocity v and some mass got added up. No, some mass was getting added up to the system. The speed of car v at the instant when the car has cleared the chute. So some let it be x, that one. I'll take this is. Okay, let's write down the equation. Oh, in what action the thrust force all. So I'll say net force acting on system. System means what? Mass getting added up and the trolley will become system. The mass which is getting added up. So in what action the velocity of that added sand with respect to trolley. Yesterday we have done this, if you can remember. Vst equal to Vt. So velocity of sand with respect to trolley. This we don't know. Velocity of sand 0, no, and velocity of trolley is v towards right, and velocity of sand with respect to trolley is vr. So what is the direction of the mass which is getting added up? It will be, okay, I'll shift it a little bit up. Once again, I'm repeating what we did earlier. So here the mass which is getting added up. In what direction it will have relative velocity? Vr. So and mass of system is adding up. So therefore in what direction the thrust force should act? The thrust force will act here like this. Now will there be any thrust force on the particle also? Yes, it should be, no, because Newton's laws of motion equal and opposite. So therefore, what is the net force on the system will be 0. So to avoid confusion, I'll just remove it. Let's get into the problem now. What is the net force acting on system? I'll say 0. What force the added mass, what the mass which is getting added to system will exert? The same force, what happened? The trolley will exert force on this particular mass. Now, what is the system? Trolley plus this is the system. The mass which is getting added up to system, and the trolley is that one. So let the total mass of system, let it be m. Now because m naught plus some mass getting added up here. Okay, let's write the equation now. What is the net force acting on system? I'll say 0. Sir, what about thrust force is acting? What thrust force will act on the trolley? The same thrust force will act on the mass which is getting added up to system. So then, so what is the basic equation here? M dv by dt plus v dm. You have to think in this way. So m dv by dt. This dv by dt is what? Acceleration. This is what? V relative. Or nothing but VR, that is VR. So what is dm by dt? Dm by dt is what? Q. This acceleration, I'll write it as v dv by dx. Okay, able to understand? No, this will be so. This will be keep as it is. Don't change it. No. What are the things like? We have to calculate the speed of this one. No? So what is mv? Initial momentum was m naught v naught. Final momentum was mv with mass get added up. Initial momentum equal to final momentum, as net force is 0 along x-axis. So therefore m naught v naught should be equal to mv. What is m? M is mass of the trolley plus mass of the sand got added up, the total mass it is. So this mv, I'll replace it here now. M naught v naught dv dx equal to minus v into q. Solving this, dv by v is equal to q by m naught v naught into dx. I'll write it below a little bit here. dv by v minus q by m naught v naught dx. So now this integrate. Initial velocity is v naught. Finally, when it attains velocity v, 0 to L. Is asking the velocity finally when it attains, no? When x equal to 0, it was it. So finally what happened when the rear end of the trolley reaches the chute, or say this particular hopper, that one. So x equal to L. Solve this. Log of Vf by V naught equal to minus QL M naught V naught. Okay, this is the expression for the speed of the truck when it is finally ended up, that one. I'll give a rough diagram. The idea of conservation of linear momentum is very important. Net force is 0 in fact. But sir, earlier you didn't do. If you take only trolley, because of that thrust force only, the velocity will change here. Okay, no. So this is the